We will be seeing the solution for the Codeforces problem not sitting. It is officially from Codeforces round 766 div 2. It is 1380 on Codeforces. So what is the problem stating? The problem is stating something like this. There we have been provided with an grid of n cross m size, and what we have to do, there is a girl and a boy. The girl named Tina and boy named Rahul. Now the boy name, I think the boy is named Rahul, yeah. So what we have to do, the Tina is provided with an k number of paints which she can use to paint the seat so that no one can sit on them. Now the Tina will select the seat according to her choice and she will just paint it out. And now the Rahul will come, and as you know that the color of the paint is pinkish, so the Rahul is kind of like resist to sit over on that particular table, and he will sit somewhere else. Now after that, once the Rahul has sit, Tina will again come and sit as far as from the Rahul, and the Rahul will try to sit as close as to Ria, or you can say as close as to Tina. Now the both of these are trying to having a opposite tendency, and we have to print for each k from 0 going till n into m minus 1, covering all the grids. We have to tell that number of what the closest distance. Now the distance which you have to taken is the Manhattan distance, which is nothing but a minus c plus b minus d modulo, or you can say absolute of these two, right? Now what is the basic formal input and output? We have to first get that integer t which will correspond to the number of test cases, and after that we will have to get each line n cross m. We will basically get only the n and m, and we have to print n into m minus 1, use from 0 to n into m minus 1. Number of these are the k, and corresponding to each k we have to print the distance. Now what is the current distance? Distance doesn't have to be maximized or minimized, but their tendency will going to be in such a manner, and both of them know their opposite the what is their tendency or what is their strategy. So both will optimize themselves in such a way that the Tina will always try to maximize her distance from that particular chair, and Bob or the boy will try to sit as close as to Tina. Now let us take the example of a test case. Now I have taken the test case from the given examples. Let us say 4,3. Now this is the grid size 4,3. Now assume where will let us say the initially the k is equals to 0. So all of these seats are available for Rahul. So Rahul will sit at a particular position such that she know that Tina will sit as far as away from him. So he will try to sit in a particular position as close as to Tina. Now if you think that he will sit over at particular distance, he will try to sit in a centrally located location. He will sit something like in the center. If he sit over here, it is kind of like a center, so his distance from Tina is this much only. But he know that if he sits somewhere else, because in a particular square you see the center is closest from the all four corners, right? Now if we sit in this particular table, then the distance is going to be increased. So as you know, the basic fundamental that the center is always closest from the four corners in a particular square. You can think of it as a square or a rectangle. So each time Tina, now once the this case is completed, now the Tina comes up with a bucket and try to paint the seat. Now she knew that the Bob or the Rahul was sitting at this particular chair. He will sit at this particular chair because this is closest from all the corners. So she will try to close it down by painting it, or she will try to omit it, right? She will paint it particularly. After that, now Rahul will look over at the other central location such that the distance is, he will try to minimize the distance. Now at this particular chair, now also once again the Tina will try to paint it. So what I'm saying that the corners are important, and you have to take an observation out over here. All of these corners will be painted at the very end, because Tina knew that these are only the locations when she can be as far as from the central locations, and Rahul will try to occupy the central locations. So she will start painting from the central locations. So what we will basically do, we knew that these are going to be painted at the very end, so we will just basically get these coordinates, and for each row we will try to get the minimum, we will try to get the maximum distance. Let us say this position is occupied, right, and this is occupied, and this can also not be occupied. So if this occupied, she can you can think of it that distance from this corner, this corner, this corner, this corner, we have to take the maximum distance. Why? Because we know that the Tina will maximize the distance. Yes, and we have to only tell the distance. So Rahul has done his job. He has seated in a particular position such that the Tina, he has allowed the Tina to go as far as possible, but he will also make sure that the distance is minimized. So he will sit it over here, and the Tina will be seated at that particular position, right? So in this particular way, from all of these four corners, we will just calculate the Manhattan distance of each node, and we will maximize these four distance, and this we will store in a particular vector, you can say, and we will just basically sort out that vector and we will print it out. If you want to see the pseudocode, let me just show you. Now we will see the pseudocode. What we will do, firstly we will get the integer t from the user. You can see over here, integer t, get it from the user. Now we will use a while t minus minus greater than 0 for covering all the particular test cases, and in each test case, we will get the integer and we will declare it first, and we will get it from the user. Now we will basically create all these edges or the coordinate systems. A row, let us call this corner A, B, C, D. Yes, let us call it A, B, C, D, and we will get it. We know it is a basic mathematics, and we will just get the corners from calculating n and m. Now what we'll do, we will contain an answer which is the kind of a long because the distance can be going to be increased. Now we will just declare the size, we will just occupy the size for this answer, and we will go from each I and j in a particular grid fashion, as you know, the typical grid traversal, and in this we will calculate the distance from this A, B, C and D, all of these four corners, and we will just finally maximize the distance at the very end, and we will just finally sort the vector, particularly the answer vector, and we will just basically output all of these elements. I hope you understand the solution. Thank you and have a good day.